Okay, good day, viewers, from wherever you're watching us. Today, I'm going to be teaching us about electrostatics. Okay, this physics class. Ele- Electric charges. Let me start with this. So, when we look at this topic, is a very important topic when you want to understand charges. So we have different studies of charges. There's a study that has to do with charges in motion. So when you're studying charges in motion, we can say that's current electricity. But if we are studying charges at rest, we say that study is electrostatics. Study of charges at rest. Another name for it is static electricity. The word static means it's stationary. So the charges are not moving, they are not in motion. So now we have this under static electricity, we have to understand that there are two types. There are two types of electric charges. So we are studying electric charges. So the first type of charge, we have the types of charges. We have number one, we have the positive charges. When you want to get the positive charge, you rub a glass rod. So you get this using the glass rod on silk. And for the negative charge, this ebonite rod on fur. So I use a small code so that students will not forget it. So you can just not let me use the code here. Write the code here. So for positive charge, hugs. So this positive charge, glass on silk, and for the negative, that's nerve. So nerve, hugs, and nerve. So nerve negative charge is gotten by rubbing the electric ebonite rod on fur. So these are the two ways of producing electric charges. So you have this positive charge, this is a glass, and this is a ebonite rod. These are the two charges that you have there. Now we have to also note that there is a law, attraction and repulsion by charges. Positive, when you have same charges, nota bene, same charges repel. Then, unlike charges, or like charges, let us say like charges, let's use the word like charges repel, unlike charges attract each other. So, if you bring a positive and a positive charge close to each other, there's going to be a repulsive force that you'll notice. Also, if you bring a negative and a negative charge, there's going to also be a repulsive force. But when you bring different charges, a positive and a negative charge, you're going to have an attraction between the two. So you can see this existence of charges in natural phenomenon. So these are ways we can explain static electricity. If you take the pen, the cover of your pen, that is made of plastic material, and you rub it vigorously on your dry hair. After rubbing it, or you rub it on your coat sleeve, you're going to have generation of what? Charges And these charges, when you bring that rod close to a small piece of paper, it's going to attract the small piece of paper, and that is what we are talking about. So another way is when you comb your hair, you discover that your hair that is made of a plastic material. You also have so we have the dry hair with comb. When you comb your dry hair with a comb, and the comb is made of a plastic material, you see some of the tufts of hair will stick to different parts of the comb. It's because of electric charges between the comb and the hair. Also, when you are ironing your material, or when in a dark room, you will observe tiny spark when you are ironing, because you are ironing the clothes. The clothes is made of plastic, of a material. You would see sparks in a dark room. Also, when you are combing the hair in a dark room, you will see tiny sparks. These are natural phenomena, or natural existence of static electricity. So there are three ways by which we can production of charges. There are three ways by which you can produce charges. Number one is by friction, and that is what I've explained to you. When you rub the plastic side of your pen, the plastic container, the holder of the pen, when you rub it vigorously on your hair, you bring it close to the paper, that is production of charges by friction. And also we have another way, we call it electrostatic induction. Electrostatic induction. This electrostatic induction has to do with what? You are not making contact with the materials. You are just bringing it close to that particular object you want to charge. So electrostatic induction, you see that if a body that has a charge is brought close to another body that does not have a charge, the electric charge can be induced in the other one. Then the last way of producing charges is by contact. By contact. So this has to do with what? We are having contact between the two materials you want to charge. Maybe you have a charge, you have a positive charge, you are bringing a negative charge close to an object, or let's say positive charge close to an object that is not charged. When there is a contact between them, there is going to be a kind of production of charges in this one. We are going to explain this better when we get to electrosporous and charging of materials. Okay, so now let's look at production of charges by electrostatic induction. Production of charges by electrostatic induction. So I have said that electrostatic induction is the act of charging a neutral body. You have a body that has no charge. When you talk about neutral body, consider this kind of body now. It has equal positive and equal negative. A neutral body, if the body is having more positive than negative, then it's a positively charged body. If it's having more negative charges than the positive, is a negatively charged body. But a neutral body, let's see that is an atom. In a neutral atom, we have equal number of electrons and protons. So also, if you're looking at a neutral body, it has equal number of positive charges and equal number of negative charges. In this case, this is not charged. This material is not charged because it's not carrying any excess charge. So a neutral body, we are bringing the act of bringing or charging a neutral body by placing a charged body near it without any contact is what we call electrostatic induction. So if we look at electrostatic induction, charging a neutral body by placing a charged body close to it without contact. The moment it has contact with it, it's no longer electrostatic induction, it's now by contact method. So let's look at an example. A conductor can be charged. Let's look at this conductor. A conductor is made of a metal. Let's say this conductor made up of a metal surface, and we have let's label this A and B side of the metal. If you we are putting this metal on an insulating material so that there won't be contact with it and the earth, and also so we can call this insulating stand. Okay, so you are mounting this conductor AB on this insulating stand. When you look at this conductor AB, is a neutral body because it has equal number of positives and equal number of negatives. Now, when you bring, the next stage is we are bringing a charged body close to it. If I bring a positively charged body close to it, something will happen here is that since this body is a neutral charge, is a neutrally charged body, a neutral conductor, sorry about that. So the positive charges will come close. All the positive charges, no, not positive. All the negative charges will come close to this side of the conductor, because positive, unlike charges attract each other. Why this positive will repel all the positive charges towards the other end of the conductor. So all the negatives, all the unlike charges will come close to the charge particle, charge rod, and while the like charges will repel to the other side. Then the next thing we are going to do here is that this is step 1, this is step 2, step 3. Then the next step is I then connect, still having this positively charged rod close to it with the negative here, and the positive here. I connect this side that has a positive, the other side, I connect it to the earth. What will happen here is that all the positive charges will flow to the earth. I hope you know that the earth is a natural reservoir of charges. So it will flow to the earth. This is the earth. And only the negative will be left. Only the negative charges will be left. By the time you remove step 4, by the time you remove this charged body, what you'll be left with is only the positive charges will be left in this system. So if we are going to produce, it's not the positive that remain, because the positive have moved down. So we are going to have the negatives. That means that to produce a charged body by a neutral body, to produce a neutral body and make it a charged body, you are going to bring the opposite of the charge you want to make it. That is, if I'm going to make this body positively charged, then I bring a negatively charged rod close to it. Also, if I'm going to make it negatively charged, you saw in this case, I brought a positively charged body close to it. And this is how we charge a conductor by electrostatic induction. On the other hand, If you're going to charge by what? Contact. Production of charges by contact. Production of body charges by contact. It's still almost like the same way, but you're having two bodies in contact with each other. Two conductors were in contact with each other. This is the insulating stand. These are the conductor. Let's say this is conductor C, conductor D, and I'm bringing a positively charged. Let me use a negatively charged rod now. I'm bringing a negatively charged rod close to this. Now, one thing that will happen in this case is that, so I hope you know that this is the negative charge, this is the insulating stand, this is the conductor. So, this is the conductor, this is the negatively charged rod, and this is the insulating stand. Now, when you have this scenario, when you bring this negatively charged rod close to this C and D are in contact with each other. This negatively charged will attract all the positive, this is having equal positive and negative, but because they are in contact now, since this one is negatively charged, it attracts all the positive to the side of this metallic sphere, and also it repels all the negative charges towards the side of the other D sphere. Now, the next thing is when you break it, this is the explanation of production of electric charges by contact method. So you have still having this charge rod still in position. So the next thing, you separate them. We are separating them. This is C, this is D. So all the positive are still on this side. All the negative are still on this side. And you see how your negatively charged rod in place. This is step 2, this is step 1, this is step 2. Okay, so the next thing is when you remove the charge rod, the negatively charged rod, what you will have is the equal distribution of the charges on each sphere. So this sphere C and sphere D, sphere C, by the time I remove this one, all the positive charges will be spread evenly inside this sphere. While for D, all the negative charges will be spread across throughout the whole material of D. So that is the concept of charging conductors by electrostatic induction and also by contact method. So the next thing we need to also understand is an instrument which we call the gold leaf electroscope. Gold leaf electroscope. The gold leaf electroscope is a material, is an instrument okay. I need to draw the diagram so that you can see it. The gold leaf electroscope we have a brass disc And this, I'll use this to represent the gold leaf. So then there's an insulator here that separates the metal rod from the metal casing. This is a metal rod. This is the brass disc. We also have the insulator. We have the metal casing. You have the gold leaf, and it can be connected to the earth too, to the earth. So this is let's draw the diagram for the earth. Yeah, this is the earth, the earthen wire. So now, what is a gold leaf electroscope? And a gold leaf electroscope is an instrument for detecting and testing. It's an instrument that we use to detect and test small electric charges. When you look at this particular instrument, or we can say device that is used for testing and detecting small electric charges. And you can see we have a flat plate here. Let me get a ruler to identify it. We have the flat brass disc. This is the flat brass disc that is there. We have the insulator. We have the metal casing. This metal casing has 4 sides, and also we would agree that the 4 sides, 2 of the sides are made with metal, and the remaining 2 are made with glass, so that you can see the divergence or the collapse of this gold leaf. So we also have that's the gold leaf. I've already explained that. So what are the uses? We have some of the uses of the gold leaf. Number 1 use is used to detect the presence of charge on a body. That's one of the use of the gold leaf. Used to detect uses to detect presence of charges. Another thing is to determine the type of charge. There are 2 things, there are 2 different things. There is one case that, okay, I is able to detect that there is a presence of a charge in a particular object or particular rod that you bring close to it. Another thing is it can also help us to determine the type of charge. Is it a positive charge or a negative charge? Also, we can also use to test. So we can use it to test the type of charge. Another thing is we can also use to test to differentiate. It's used to differentiate between to differentiate metal, or let's say it's used to differentiate conductor in conductor and insulator. To differentiate between conductor and insulator. And also it's also used to measure potential difference as an electrostatic voltmeter. Also is also used to compare. We use it to compare the magnitude of different charges. Comparing magnitude of different charges. So, and the last one, we use it to measure ionization current in air, to measure ionization current in air. So then we look at an important aspect. How do we charge the electroscope? There are different ways by which we can charge the gold leaf electroscope. We can charge it either by contact or by induction. What we mean by contact means that what? I have the gold leaf. If I bring a positively charged rod close on it, then I'm going to charge. That's by contact. So let's look at the first way of doing it. So by contact, this is done by rolling the charge body on the cap of the electroscope. So if I have a charge body, this is the cap, the brass disc. I keep on rolling. Let's say this is a positive charge. I keep on rolling it on this brass cap, and with that, the charge from the body is conducted to the brass plate, and the gold leaf, you will see it in the appearance of the gold leaf. There will be a change in the position of the gold leaf. Is either it is diverging or collapsing. So, but since it's becoming charged, if it is a positive charge, the positive charge will be gained by this, and you see that since the same charges are now on this, there will be divergence in this gold leaf, the gold leaf, which is in the gold leaf electroscope. So since the plate and the leaf possess the same charge, the leaf will be seen to diverge, and then the body is removed. Once you see the divergence, you can remove the charged body. Then by that, your brass disc or the old gold leaf has become charged. So if I want to make a gold leaf charged by contact, I want to make it negatively charged. I'll bring a negatively charged rod on it. I keep rubbing it on it, and you see that since the negative charges will be conducted through all the metal parts, the gold leaf will get the charges, and since it's having the same charge, the like charges repel, so there will be repulsion of the gold leaf, which shows divergence. So you can it's not as reliable as induction. So let's quickly look at charging of the gold leaf by induction. If I'm to charge the gold leaf by induction, that means we are not touching the charge body is not coming in contact with the gold leaf, but we are only bringing it close to the gold leaf. So we still have the first case is if I want to charge let's use, if you're going to make the gold leaf positively charged, use a negatively charged rod. So let's bring a negatively charged rod. Negatively charged rod is brought close to the gold leaf electroscope. When you bring the negatively charged rod close to this, it is not having contact, unlike the first case I explained that you're having to rub the charged rod on the brass disc to conduct the charge throughout the whole brass disc and the metal rod that is here and the gold leaf. But in this case, you are only bringing it close. There is a gap, so you are bringing it close to it. Now, from our knowledge of electrostatics, we have proved beyond reasonable doubt that unlike charges always repel. So this negative charge will attract. Sorry, unlike charges always attract. These are unlike charges, negative and positive. So this negative rod attract all the positive. This is a neutral atom or neutral material. That means that equal number of positive and equal number of negative. But in this case, all the positive are attracted since this is a negatively charged rod. And in this case, we have the positive here, then all the negatives are now repelled. The negatives are repelled towards this place. So if they are repelled towards this place, since they are of the same charge now, there will be divergence in the gold leaf. The next stage is you connect the gold leaf electroscope, or you can touch it. Make sure you are connected to the ground, or that is you are stepping on the normal floor, not with a slippers or insulating material. Either you touch it with your hand and step on the ground, or you connect. If you connect, these are the negative charges here. When you connect, the next stage, okay, let me draw this again. And I have this. This is still here. When you touch this, so let's say we connect it to the earth, all the negatives pass through this. They move to the earth, which is the natural reservoir. Then by the time I remove this, and I have, so when you remove the charge body, which is negative charge, these charges now spread out. And since they also spread out, it's only like charges that are here at the, so there will be at the gold leaf end, there will be a repulsion between them. So the positive charges are here, now here. So this, by this, we have charged this gold leaf positively. So it's now a positively charged gold leaf. So, and that's how to charge it by electrostatic induction. Okay, then let's look at a summary of you need to know this too, because it's very important to understand the way the charges will behave, or the gold leaf will behave in different situations. Once you understand this summary, and I will just explain a bit. So let's look at the summary of the effect of on the gold leaf of a charged electroscope when a charged material is brought close to it. Let me clean this. Okay, I can drop my line here. I have 3 lines. So the first table, let's say charge on electroscope. Then charge brought near the cap, and also effect on the gold leaf, So this is a kind of summary, instead of drawing all this like in different cases. So let's summarize all this in a table. Number one, if my gold leaf is negatively charged, so 1, negative charge. If you have a negatively charged electroscope, when you bring a negative charge close to it, negative charge is a charge you are bringing here. when you bring a negatively charged close to it. One thing is this, let's assume that you have a negatively charged electroscope. You are bringing a negatively charged rod close to it. This negative charge will repel all the negatives that are here, and that will cause more divergence. Divergence what? Divergence increases. Divergence increases. If I'm bringing a positively charge close to this negative charge, let me summarize it. Negative charge, and I'm also having a positive charge being brought close to it. If I bring a positive charge close to this, it will attract all the since there is always an attraction between unlike charges, this positive charge that is brought close to it will attract all the negatives, most of the negative. Thereby, the effect we will see is collapse. There will be a collapse in the divergence. That means we can say divergence decreases. Now, let's look at if I'm having a positive charge, this positive charge, and I'm bringing a negative charge close to it. Same thing, there is a positively charged gold leaf, a positively charged gold leaf, and bringing a negative charge close to it. It will attract all the positives, and there will be what? Decrease in divergence. So divergence decreases. If I have a positive charge electroscope and I'm bringing a positive charge close to it, I have a positive, look at it, a positively charged electroscope. I am bringing a positive charge close to it. It will repel most of these charges, it will repel them towards the gold leaf. Thereby, the divergence increases. 5. If I have a positive, let's look at a positive charge rod, electroscope, and the last one, negative charge electroscope. I am bringing uncharged body. So if we have uncharged body, so in this case, I have the gold leaf. For positively charged gold leaf, this does not have a charge. The charges of this can be rubbed on this, thereby the divergence decreases. So divergence decreases. Also, for negative charge, the divergence also decreases because it's losing some charges to the uncharged body. So and this is summary of the effect of charges brought on the gold leaf of an electroscope. So then you must also know okay, I think in the next class I'll be telling us about distribution of charges. But let me just give you a brief understanding. When you have a pear-shaped conductor standing on an insulating material, always note that the charges are more on the sharp point you have dense population of charges here. The charges are more concentrated on this. If you have a circular, the charges are spread around equally, even distribution of charges. If you have a rectangular, you have a distribution of charges on all the surfaces, but at the corners you have more. At the corners you have more. At the corners you have more. You have more here. And for a hollow material, the charges, when you look at a hollow material, the charges are always inside and outside. So I will stop there. I'll see you in the next class. Remain blessed. Please subscribe to this channel.